Hello. We are on. Slightly late, but whatever. Waking up is hard. Even if you have a reason to. It's fun. Hello, hello. How long did it take? How long was it? It's like a year-ish. Something like that. Cool. Codeforces. Why I'm not doing Echo anymore, I just don't really like it. I'm not happy with their problem style. I don't really find it fun, so I just don't want to do it. I can't. I understand the dissonance in performance now. I can't do well in problems I don't enjoy. And usually on Codeforces I like the problems. They're like interesting, unique, different. This is new. Okay. Interesting. No, but yeah, I don't really like it. What was I gonna check? Damn. This. Grandmaster. Yeah, it took me about a year. Um, Still applicable today? Yeah. Depends on a lot of factors. Mostly optimal practice strategy, which is really hard to come by. If you want my current advice on that, see the description, but I will update it later. How many hours a day? A lot in the beginning, and then less later. Like a lot in the beginning, like a ton. Not as much as now, but like pretty much around that time line. Okay. Cool. How hard are you? Yeah, we can do you. Sure. Maybe like 32. Hello, hello. What's up? Covered it with dominoes. Yeah. There's exactly one domino from the board, freeing two of the cells. Next, he moves dominoes around. I don't know about leak code. It's gotten hard recently, right? So I've heard. Only the two free cells of the board can be identified. Sorry. Each domino shares at least one cell with its original position. UDLRLR, right? So we have directed components, right? How does that work? Finish Chrome update, yeah. I'll do that never, probably. Fine, I'll look at it. I'll look at it to start. Quick warm up, I suppose. Contest. This one? Suppose. Wait, this one? Well, what do you mean? It took 30 minutes for people to finish. Well, that's actually crazy. So what the hell? That is not a 2-minute solve. What are you talking about? Zero index string S. What's K? Okay. Wow, so we for each suffix, calculate the amount of partitions you get when you start there, and then for each partition for each group in the initial partition, you make it as long as possible, I suppose. And by greedy observation, you want to make it last as long as possible. Okay, sounds fun. Well, you make it as short as possible. Okay, sounds fun. Sure. Okay, that's LeetCode. Let's get back to interesting stuff. So, components are independent because chessboard. So if we remove a domino, then we have a not dag. Is it a dag? Wait. So you can move here. Then you can move here. What does this graph look like? Is it a dag or a tree? If it's a tree, that makes life easier. Wait, what do you mean brute force? Oh, why would that work? That doesn't seem like it should work. So 2 to the 26? I don't understand. I mean, the number of visited states is small, sure, but that seems kind of like a cheese. Actually, I don't really need the bit mask, because like, you're pretty much always going to change it to a character that doesn't exist. Yeah, it's like, okay, it's like n times 26 squared. Sure. I guess you could do that. So, problem is the states are not independent. Oh, you can always, okay. You're always going to move 2. Which means that if you're in the same column, you're going to always stay in the same column mod 2. This graph is strange. LR. Right. So if we remove that, the reachable states are definitely not independent, right? Like LR, UD, right? The move down, or rather, LR here. Wait. LR. Are they independent? Not really, right? LR. LR. So we have LR, 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 right? So you end up here. Then UD. Then LR. Then UD. Then LR. It's like LR, right? UD. If this, you can move down to oh, wait. Oh, no, what am I saying? Okay, yeah, wait. No, wait, what? Wait. Move 10 apart. So move 9 apart. Move down 2. Move 5 apart. It's like LR, 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 right? Move down. Move inside. Now you're 5 apart. Move down. Then move here. Now you're 5 apart. Wait, what? Wait. How would this work? Because you have to be like inside this. No, but that doesn't change anything. So we have LR. And there definitely is repeat among states. Like simply put, you can be here or you can be here. We have a streak of L's and R's. Let's say. Oh, this is tricky. This is tricky and fun and annoying. How do you generate a random dominant tiling? It's actually kind of an interesting problem. We can brute force all tilings, I guess, but then what? I don't know, it's a matching, I guess. So you can generate a random matching. But like weird. That's weird. That's weird and tricky and weird. So We could have LR, right? Then add a down here and an up here. I mean, it does become a dag. But it's a really strange dag. So we got 10 of you, right? And then we have like an up down everywhere here. Yeah, and you're gonna switch parity. Okay, cycles. We can have cycles, right? You can go here, you can go here, you can go here, you can go here. We can have cycles. No, we can't. Can you? Can we prove that if we have a cycle, well, the thing about that bitmask thing is like because you can make only one move, like the number of states is probably only like 26 squared. So it's probably fine, but theoretically it should not work. But I think in practice it will work. What does a cycle look like? So this, and then this, and then this, and then this. All right, we're going to do some wishful thinking, and we're going to hope that a cycle always has an odd number of cells inside. Therefore, it's a DAG. Wishful thinking. So then what? How did that happen? For any streaks of L's and R's, we have pain. For any streaks of L's and R's. Alright, we can obtain any pair on them. And then what? Struggling bit manipulation. Struggling what? Like, what about it? I have not heard of this book. I don't really look at books. Org indeed. I mean, it's not reversible. Problem doesn't look fun. I don't know though. Endigorian's usually a good setter. He's made some of my favorite problems, so I'm not sure. Not sure what to think about this problem. Is it a dag or a tree? Should be a tree, right? Every node has exactly one parent. Yes, I'm at that point. There's little nodes. Well, depends on the platform. Codeforces definitely. I don't know about other sites. Other sites are weird. There are a lot of things I don't know. But on Codeforces, most of them don't matter. I'll still die on some like generating function problems or convolution, stuff like that, but most things I'm fine with. That's why I like Codeforces, because I don't have to learn a bunch of obscure things. Adamance blocks, yeah, sure. Very, very useful stuff. Very useful. Very applicable. Very, practical. Coder, probably. Coder grand contests are like probably some of the hardest contests ever. They're usually harder than div ones. Okay, what is with this problem? Yeah, okay. Although, I mean, difficulty of problems is not really relevant unless LGMs are able to full solve, I suppose. So any R invites an edge like this, and any L invites an edge like this, but not both. That's pretty much the only like constraint we have, right? That we can't have both. We can have LR, we can have UD, right? Then U. Then like U to some extent can go here. And we're fixing that you're going to stay here. And if you're going to stay here, then none of this matters, right? Fixing that you're going to stay here. If you're going to stay here, then we don't care about these. It's the only states where you're both simultaneously possible. No, but that's tricky. Because that's not going to get all of them. Because you could be here, and you could be down here. So we have this tree structure. I guess like what we need to do is that introduces another problem. Yeah, but you're gonna be odd, so that's fine. Yeah, that's fine. And you're 4 apart. LR. I do eat, but I just don't take a break from it. From train. Interesting. I do eat, I just don't take a break. I just solve problems while. I've done ICPC once. I'm going to World Finals 23. Hopefully, if that ever happens. Which it may never happen. May just never happen. Like that contest may just never happen. I don't know. So you can be here, you can be here, you can be here, right? Then we can't like, you can be here, you can be here, but we can't ever reconcile you. Because again, it's a tree. Okay, yes, it is a tree. We're given some trees. I want to find the highest node that you can reach. I'm not doing echo today. That's probably not again. Don't really want to. OR. So, I mean, you could go up. Then we end up in a legal state. Then we have to somehow combine these two trees. To somehow combine these two trees. Can we think about this more objectively? Like, from the perspective of... Wait. Oh, wait. No, wait, hang on. Wait, what am I saying? Okay, I'm mildly confused. um... So, I mean, yeah, we can end up with... Can end up with odd space, even space, or both. So anywhere on the same line is like objectively the same. They're gonna end up with odd space, even space, or both. Where does odd space end up? I could subtract the illegal states. It's gonna be really annoying to debug. These are not independent. I just realized these are not independent. Oh, that's awesome. Okay, that actually might make the problem easier. Or it might make it harder. Might make the problem harder. Does it make the problem harder or easier? Probably makes it harder, right? For any pair of cells, there should be exactly one way to attain that, right? At most one way. These, okay, that makes it weird. These now form a cycle. I can move you here. 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 Is anything attainable in here? Hey, what's up? This problem is fun. Now I have to rethink everything. That's great. I mean, if we remove you, then you aren't gonna budge. If we remove one of you, all of those are valid. So removing an LR and a UD are completely independent. Which makes life a little bit easier, I guess. Makes life a little bit easier. So why don't we just figure out LRs? Then we could transpose the graph. So if we remove an LR, UDs can move at most once. LRs can move at most twice. So if we remove one LR, it's equivalent to removing any LR on here. Hello. Hello. Stuff. It'll be less about uni and more about the fact that I need to put time into YouTube too. So I will. Probably split it at least in half. Hello. So for some given thing, so we're back to this. You can move simultaneously. So if we had like like this. And this is tricky. Because now this top LR is reachable. But not really. And this top LR is reachable, but it can't reach anything else. So we do have a directed relation. We have the cyclic relation right next to it. How do we characterize this? So, I mean, given some particular LR, so suddenly, like, now the number of states gets complicated. So considering some particular LR, yeah, there's some group of LRs, sure. For any UD that goes up, considering some particular LR, So we have to characterize the reachable states somehow. So consider removing some LR. So if we consider removing on this range, we can obtain any of these states. Will I do anything in the near future? No, probably not. Not until I'm ready for LGM. I don't see a point otherwise. Damn, this is hard. LR. So, I mean, if you're together... So, I mean, if you're together... I mean, okay, so we consider you separately. Then if you're here... Here's something like this. If this cell was uncovered... We're conditioning on the fact that this cell was uncovered. This cell is uncovered. Man, if this cell is uncovered, what should we could do? Means that you're down. Any cell here is down. If this cell, so the cell in LR is uncovered. We might as well assume that the LR is gone. The cell here is uncovered. What does it mean? What does it mean for you? What does it mean for you to be uncovered? If a cell here is uncovered, if you're the left of an LR, is there ever a reason to assume that the R is here? And supposing the R is here, then what that means is that this is moved this way. Which means that whatever was here is gone. Well, this cell is uncovered. Yeah. That means that leaves two possibilities. Either you were moved this way, which means that you must be moved this way, which means that you must either be gone or moved this way. Or it means that you're gone. Now that's only two possibilities, which isn't actually that many possibilities. Two is a small number. So if this was moved this way, that means that either this is gone or you are moved this way as well. Like if we're on an LR, if we're on an RL, that means that either this is gone or you were moved that way. No, but we're assuming you're not gone. So if you're uncovered, if this cell is uncovered, that means that this was moved to this way, which means that whatever cell is moved here was moved up one. So whatever is here was moved out of the way. And we follow this chain. Until we eventually arrive at something that was moved, right? So for a given cell, there's only a certain set of things that could have been done. So if we have LR here, if you were moved to the, then that means you were moved down. That means either you were removed or not. We assume there's no cycles because wishful thinking. Then you were moved this way. So you were moved this way. So you were moved this way. So you could have been removed. And if you were removed, is this unique? Wait, is this unique? Wait up. Wait up. Wait up. Is this unique? Is this actually unique? Let's consider Right. So if we assume you were removed, then you were moved this way, 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 then you were moved this way. Is this actually unique? Does this actually work? Fix a left cell, and we count how many possible right cells there are. So if you were removed, Wait, not necessarily, right? So if you were moved this way, then you were moved this way. If you were moved this way, then you were moved this way. So that could be removed. That leaves this and this. So I mean, if you were removed, and that would leave this and this. Then you were moved this way, which means you were moved this way, which means you would be here. Or we could do this and this, which doesn't necessarily become unique. Yeah, Nutella is legendary Grandmaster. People made that association a lot. Okay. But I mean, you could be necessary. Because you might not be able to reach this. LR. We fix that you're gone. We fix that you're gone. Either you are removed or this was moved. If this was moved, then this was moved, then... Wait, what? Wait. Yeah, no, wait, yeah. This was moved. Then either this was removed. Or this was moved this way. Which means this was removed and this was removed. Again, this could also be LR, right? And then this would just not be reachable otherwise. Two seconds. Good to know. Okay, but again, this is a tree relation. This is a tree relation. which means that anything here will be the same as anything this is a tree relation, which means that if this reaches this, and this cannot reach this, so we can remove this, and then this would be here. Or we could remove this, and then this would be here. Or we could remove this, and then this would be here. Or we could remove this, and then this would be here, and then this would be here. So, I mean, you're going to have exactly one, like, descendant, right? We have multiple trees again. It's like you're going to have exactly one ancestor here. And this ancestor has all these possible things. And this ancestor has all these possible things. This ancestor has all these possible things. LR. If we remove you, right? They don't particularly care about these cycles. Like, for the perspective of fixing an L, this cycle doesn't really matter. From the perspective of fixing an L, this cycle doesn't really matter, right? All we need to do then is A, determine the reachability, then B, so we could have removed this, which means we could have removed this. So we get all these possibilities from removing this. And then we just have these extra ones. But because this is a tree... No, that's not how that works. Is that how that works? How does that work? because this is a tree, because you're going to have exactly one ancestor, if you have this as an ancestor, we don't particularly care about you. If you have this as an ancestor, then we don't particularly care about you, right? So then consider the things that feed into you, right? Then once you're gone, what we can do with this left doesn't particularly matter. All that matters is what we can do with this right. This feels like it works. Feels like it works. The issue is complexity. I mean, we can hope that the graph is not malformed because of grid, but that feels kind of sus, right? Because like we could have this enormous chain of stuff. And none of it gets reached, right? I'll be right back. Okay. Yeah, I'm alive. Just beaten down. Beaten down and destroyed by repeated difficulty. So, I mean, you could form this enormous chain of regret and hopelessness. And there's nothing we could do about that. Right? How does this work? And if we form this tree, it's like, it's so annoying. Like, we could try and bit set this, but I don't know about that, man. I don't know about it. It's probably not gonna work, right? It's probably not going to work. Is DSA what they like refer to as the interview stuff? Oh, jeez. Okay. I'm noting that my hair is a mess, which is awesome. Great. So. And you could just form some massive tree, right? And we can't just, like, we can't just do that. We also can't so, like, there are two trees going on here. There's the starting tree, which we can use to do stuff. I see. We have this, hello, we have this starting tree. Which goes like this. So we go up and this way. Which is what we get when we remove this. Like we have the set of reachable things when we remove this. We also have the union now with the set of reachable things when we remove the next part. And you're going to be all of this. And that's a freaking bit set and a half, which is not going to pass in time. So we need to not do that. We need to not do that, right? We need to not use bit sets. Bit sets is probably not going to work. I think this reduction is fine. That you could require this, and then we could have a mirrored thing here. Wait, can we? Yes. LR. Then you'd be here. Then you'd be UD. Then you'd have to move up. And you both feed into this. Then we remove you. Then you'd both have something here. I see the issue. So we have the tree for the even spaces. We have the tree for the odd spaces. And the tree for the even spaces is descendant. Is where we're looking at we're going up. And the tree for the odd spaces is we're going down. And for this tree for the even spaces, so we have this reachable set of things. Wait. Oh. 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 If you are like this, well, no. Not necessarily, right? Because, I mean, then this could be mean. And this could reach up here. Then this could reach up here. Then this could reach up here. Right, and that's going to be problematic. Wait, can you? It is a tree. You are a tree. You are a tree. That's really annoying. That's really unfortunate. I mean, you have some set of parents. Right, and this could be LR. That means that this is parent is this, and this is parent is this. And then this reaches this, and this is all innocent. How does this work, man? How does this work? We have some dependencies. I don't know what I'm saying. I have some dependencies. So we send you in a direction. But you're still a tree. Wait. Right? Yeah, I can't necessarily reach you, but I could reach one of you. It's not necessarily true that this reaches this in the tree. It happens to be true here, but it's not necessarily true. All that needs to happen is this needs to jump to this. But if you don't reach you, then you're completely independent. So is that how this works? Is that how this works? So we do some wacky DFS. So if you reach you, then because it's a tree, nothing else can reach you. So we want to exclude everything that's a parent of you here, and everything that's reachable by a parent of you. But if we reach you, then we cannot simultaneously reach you, because otherwise then you would have multiple parents. So if this reaches you, then this cannot reach you. Without first going through this. Wait, what? Huh. Well, this is interesting. This is an interesting idea. So we don't need to bits at you because you're a tree. We don't need to bits at you because you're a tree. That's the interesting part, right? So we can get everything that you can reach. But then we can also get everything that this parent can reach. No cycles because wishful thinking. Again. So this is everything that you can reach, and this is everything that this parent can reach. So the final, holy crap. This is crazy. So the final algorithm is determine the tree of reachability. Then this is crazy. This is crazy. This is insane. Determine the tree of reachability. Then determine the other tree of reachability. DFS from every root. Okay, what about the things that aren't This is crazy. Oh my god, this is crazy. Okay. Okay. So yeah, right? Like we need a segment tree. And oh my god, this is blowing my mind. This is insane. I don't think this is intended, but this is insane. This works, right? This works. For you to be here, either you must be removed, or this must be shifted up, right? And then you can be removed. And then this must be shifted up. Or this must be shifted up. Right, so it's any LR such that you work. Let me add you to the subtree in the first tree of you. So if you're an L and you're on the right parity, let him cook. Yeah, I swear this is not intended. I swear to God, this is not intended. I swear to God, this thing I've just spent 3 hours coming up with is not freaking intended. But oh my God. Okay, let's do this. Oh, this is insane. This is insane. This is crazy. Freaking 3200s, man. My God. So we need a segment tree. We need some t. Long count. Count 1. We don't need Novi. Okay, so lazy eye. No, your range adds, so that's fine. Now let's do. I really need to fix my frickin' segment tree. How long? Just rewrite. Just gonna add that there. Turn tree I as RL. So you're 0. Why is the door ringing? Okay. Oh, we gotta deliver. Okay, whatever. Not a concern. Okay, so if val is less than other dot val, return this. If val is greater than other dot val, return other. Return some t. Return some t. Val count plus other dot count. Val plus v dot val count. Lazy eye is 0. Okay, I should mention there's also a chance that I'm gonna just randomly lose power today. So given the stream may end early. Not by my choice, but we'll see how that goes, I suppose. Val is less than that val, return this. Val plus v. Okay, so turn num t. Yeah. If not, I'll keep coding it and then just submit it at the end after everything clears up. MTA's query. This should all work, right? My second tree isn't that bad, right? Yeah, okay, that's fine. Now, sand and m vector car v. Okay. Console dr4 is equal to left, right, up, down. So 0, 0, negative 1, 1. Negative 1, 1, 0, 0. So for li0 and v and vij is equal to vji. Okay, so yeah, out. For I0 is an S. Out I dot clear, out 2 I dot clear, t is equal to -1. So what we need to do is say for each of you, well, we don't care about the ones that aren't on the right parity, but let's just bool valid LR, LC, return R is greater than equal to 0, and R is n. Freaking boy, I should template this. I'm gonna screw it up, so whatever. For li0 is less than n, I plus plus, for lj is 0. D is equal to vi rev vij xor 1. Right, I'm gonna flip you. nr is equal to I plus drd times 2, and c is j plus dcd times 2. If valid, nr and c. Then what do we do? So if I mod 2 is equal to A, then we add U in terms of the second tree. So GID. Plus ID GID. So you're going to be a child of you. Yeah. This tree is going to, yeah, okay, it's actually the same construction. IJ, right? You're going to be a child. This is going to be a child. IJ. This is the second one. So out to GID nr and c dot push back gid ij. If I mod 2 is equal to a and j mod 2 is not equal to b, we do the same thing, except now you're here. For I is 0, I is less than I plus plus. If id I is equal to 0, dfs dst I void dst stv is equal to plus plus t for x out v dstx. Okay, now we DFS in the second tree. We DFS in the second tree. If id2 I is equal to 0. DFS I void DFS LV LP. No, we don't need P. So if auto RC is equal to decomp V, if if GRC is equal to R, C mod 2 is not equal to B. Wait. GRC is equal to L, then seg tree sum t seg. seg dynit s. Don't need you. Okay. Seg.update stv env1. Stop it. Yes, I understand the compiler. Thank you. 4lx out 2v dfsx. Okay. Multi-tests, right? No. PRG. Segfault. Where do we make it? Zero. Okay. The annoying thing about this debugging is that I can't really make my own samples, so I can't really stress test, which is a pain. Wait, okay. Oh, flip. Yeah. Okay. 74. Damn. 5. Okay, good. So you shouldn't be 5, you should be 6. I know why. That's kind of annoying, actually. So we can just, int plus equals n times m. 0 n times m minus 1. $119. Ah, damn it. Okay. C into n to m. All right. So G is vector car, n vector car m. I 0 up to n, j 0 up to m, c into g I j. Okay. So IT is 0 up to 2, for A is 0 up to 2, for B is 0 up to 2, for I is 0, I is less than minus I plus plus, out I dot clear, out to I dot clear. So reset ID, ID2, reset T, reset seg. Create the adjacencies. So D is rev GIJX are 1. NR is I plus DRD times 2. And C is J plus DCD times 2. If valid NR and C, if I mod 2 is A. Let's try these. Let's just try these. Well, let's read the code anyway. But so I plus DRD times 2. Yes. Then we are going to add an edge saying that this is the parent of this. Valid NR and C. If I mod 2 is A and J mod 2 is B, then plus plus ID2 GID IJ out to GID NR and C. Yeah. And then same thing here. Auto RC is decomp I. If R mod 2 is A and C mod 2 is not equal to B, then DST. DSTX, ENV is T. Auto RC is decomp I. If R mod 2 is A and C mod 2 is B, and ID I is 0, DFSI. Okay, so what is the answer for you? So if we remove LR, we have, I don't actually know what the answer is. Let's just look at this subjectively. Right, so A is 0, B is 0. So this is where most of the answer comes from. And we're undercounting here, I think, right? So like you... Okay, so V is 10, answer is 1. That's not true already. Why are you not true? If GRC is L, st dot update. Oh, right. That's way bigger. I'm not sure if that's right. I have no idea if that's right. No. Okay. Wait, what? Wait, hang on. Wait, this kind of feels like it's right though. Shouldn't it be? Shouldn't it be? Why are you 655? That's if GRC is L, right, then we know that we have an R to the right of you. So we're interested in the children of U. Okay. That's so much bigger. V is 10, answer is 2. Yes, that's true. V is 2, answer is 4. Because it means that we had to remove LR. Yeah. So V is 0. Something's very weird here. G. Are we flipping you wrong? ULR. ULR, DLR, LRU, LRD. No, that's fine. Turn R times M plus C. So we're not gonna, you're all independent. This feels like it should be more correct, but somehow it's like way off. I don't understand why. Because this actually makes sense. It's somehow you're just completely missing the mark. Completely missing the mark. How are you completely missing the mark? You should be 4. If we removed you, or we removed you, then you could be gone, and then you could be gone. So you should be 4. And you should also be 4, because you could be gone, you could be gone. So this is all correct. And then, so 12 is correct here. 12 is definitely correct here. So auto RC is decomp V. If GRC is L, seg.update. Oh, that's why. That's why. I forgot to update it. Bro. Okay. That's annoying. That's annoying. GRC is L. Now we're overcounting. Oh, that's awesome. Okay, I mean, let's like 4, 3. Right, so LR, so ULR, DLR, LRU, LRD. Let's also try like UU, LR, DD, UU, LRUU. Let's try some invariants. You should also be 20, right? No, okay, so something's wrong. Something's very wrong with this. Because I mean, oh, that's why. Okay. Should also be 20. Yeah. So ULR. ULR, right. So we could remove this. Or we could remove this. And then have U. Or we could remove this. So you have 1. You have 1. You have 2. Then you have 1. How does this work? You have 1, you have 1, you have 2. Wait, how does this work? So if we remove this LR, we have 1 possibility. If we remove this LR, we have 2 possibilities. If we remove this LR, we have 2 possibilities. No, we have 3. Okay, I see. Yes. I see. Then you have 1 possibility. So you should be 20. So I guess we look at this more in depth. So 24, right? So 28 is the only one for which we should get 1. 28. So 28, right? So we can move you. So we can not move you. And that's 1. We can move you, and that's 2. We can move you, and that's 3. We can move you, and that's 4. We can move you, and that's 5. We can move you, and that's 6. We can move you, and that's 7. And that's it. Okay, that makes sense. Sure. Let's check the segment tree. Check the segment tree for bugs. Long val, long count. Static const long null v is 189. Sum t val 189 count 0. Sum t long v val v count 1. Is that what we want? Wait. Yeah, right. Turn tree I is 0. Turn tree I. Sum t lazy op love v in size. Turn sum t val plus v count. Val is less than other dot val, return this. Val is greater than other dot val, return other. Turn sum t val count plus other dot count. Turn tree I, return num t. Yeah, it makes sense. Sure. Okay, so that should be the only one for this. Then we do u. So we're going to be 1, 3, 5. 1 to 31. So 27 is this one, which has... So if we want to remove you, we'd have to go out of the board. Okay, 27. 25. You have exactly 1. If we wanted to remove you, we'd have to remove this, which would have to go out of the board. 29 would be this. If we wanted to remove this, we'd have to go out of the board. 17 would be this. If we wanted to remove this, we'd have to remove this. Which means we'd have to remove this, which means we'd have to remove this. Which wouldn't work. Yeah. So 5, same deal. 15. So 0, 1, 2, 3. So this one. If we remove you, we could do this, we could do this. You have 10, that's true. 3. If we remove this, to remove this, we'd have to remove this, which is fine. Then you'd have 2, yes. V is 1. If we do this, to remove you, we'd have to remove you. So we could do this. We could have 1, 2. So we could have 1, 2, 3, or 4. So you should be 6, you should be 12. V is 13, so this one. If we were to remove this, you have to remove this. You have to remove this or this. So same as you, right? Could be this, 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 or this. And none else. So that's fine. Now we're doing odd even. So to remove you, yeah, to remove you, we'd have to do this. To remove you, we'd have to remove you. Are any of you interesting? He's 34. Yeah, this is the only one we could actually remove. And it says 21. And it says 21, yes. Okay, now we do odd. So 9 is this. To move this, we have to go out of the board. 11 is this. 23 is this. 21. So for you to be free, we have to remove this, or we remove this. If we remove this, then you're 1. This is really painful. No, there's gotta be a better way to do this, but I don't know, man. We're looking for a discrepancy. I could probably write a brute force, like a BFS, and do this better, but whatever. V's 19. That's here. So we can remove this, then remove this. We can remove this, then move this. So we could remove this. Okay, yes. So you should be 25. V equals 7 is this one. So for you to be clear, we could remove this or remove this. So we can remove this here. So you could be this or this or this. 33. $33 would be this. So we can remove this and have 1. 31 would be this. So we could remove this or remove this. 35 would be this, so we can remove this. Okay, so we're getting the other case wrong. So let's flip you, right? So LR, LR, LR. UD, LL. So LR, LR. UU, DDD. Alright, so now we have UULR, DD, UU. Yeah. Okay. So how does this work? V equals 4. So we can remove U. So we have to remove this one. So then U could move up. And that's 2. We can remove this. We can remove this, right? Or we can remove this. So we can get this, this, or this, or this, or this. Wait, what? This, or this, or this, or this. That's 4. Or this, or this. That's, yeah, okay. V is 0. Then we also get this one. Yeah, okay. Man, this is really gonna be down to the wire, huh? So you could be this. And that's 7, yes. V is 14. You could be 7. V is 26. V is 26. You're also 7. V is 24. That makes sense. V is 16, which is this one. Then we can remove this. And then these two. V is 28. No. Okay, so that's correct. Now we do odd, even. No, yeah, even, odd, whatever. So here off, here off, here off. 17. I love manual debugging, man. Here off, here off. Here, you go here off. Oh, V is 13. So here, we can remove you. Then we can remove you. We can remove you. Or we could go here and then off. 27, which is this. So here, here, off. 25, here, off. 29, off. Okay. We're almost there. We're almost at fine. We're almost about to realize that the idea is wrong. That's what we're doing, right? We're almost about to realize that the idea is wrong. V is 22. So this is 6. 6, 12, 18. Wait, what? 6, 18, 22. So we can remove this. Then we can remove this or this. That's 3, sure. Or 10. Then we could push this down, then do either of these. Yes. Or 34, same deal. Could push you up or do either of these. 32. So this is where it gets complicated, right? So we could remove this. And then do this, or this, or this. So we could get this, 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 this. Or this. Or this. So you should be 7. B is 20. Then you point to this, so you should be the same. B is 18. So you point to this, so you should be 8. B is 6, so you point to this, so you should be 8. B is 8, so you point to this, so you should be 8. Or V is 30. So you point to this, so you should be 8. So either we're wrong here or I'm counting wrong. No, I'm counting wrong. Wait, what the hell? Wait, what the hell? What? So I'm missing something. I'm missing something, right? So if we do this, we could have you be here, or you could be here. So if we're doing this, then you could be this. Or we can move this here, remove this, right? We get this, 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 or this, or this. Or this. I don't see the issue with that. Something's going very wrong. And we're forcing this space to be open. Right? We're forcing this space to be open. This is concerning. Let's just see, like, you can be here, here, or here, or here, or here, or here. Yeah, that's fine. basic case, right? Should be 30, yeah. Okay, well this is the worst. Not only have I not realized I'm wrong, I realized that I'm counting wrong. Set merging, I solved it eventually. I had an extra log above the intended solution, but I had so many optimizations that it worked. I never did this, did I? Yeah, it's this problem, sorry. It's in the description now. And I mean, we have a solution that should work, but for whatever reason, it's wrong. And I'm not sure why. Auto RC is decomp v. grc is L. Seg.update stv plus 1, env plus 1. Ants plus equals n times m. Wait. How does this work? I have no idea if this is right. How does this work? All right, so we could remove. So for this square, we could have 4. You should be 4. Yeah. For v is 2, we could remove you, and that'd be 4. For v is 8, right? We could remove you. And then do that, and then do that, or do that. For v is 10, we could remove you, and the answer is 10. We'd have LR, LR. Right, so we can remove you, and then you'd have this, and you'd have this. We can remove you, and then you'd have this, and you'd have this. Or we can remove you, yeah. I'm really confused. Okay, so we're gonna have to write a brute force for this, I guess. It was yesterday. I got it at the very end of last stream, and then I pretty much ended. You can see it then if you want. Freaking hard problem. Okay, so Okay. Void brute. Um, if um, um, yeah, yeah. Why? Wait. Okay. Good. Okay. So if you're on a different column, C mod 2 is not equal to C2. Okay, now we debug. Now we debug. Now we stare at some numbers. So R is 4, 0. Into 0. R is 2, 0. Into 0. 0, 0. Okay. 4, 4. Into 7. 4, 4. Oh, now you're gonna double, that's fine. Because we just need this. Wait, what? Yeah. Okay, yes. Now we stare at some numbers. How old am I? 20, unfortunately. And I'm still doing this. Okay. 4, 1, 1. 4, 5, 1. Oh, this is all screwed up. Still. It's not a... yeah. Whatever. It's not the best idea to be doing this at any point. Um, um, how do we do this? How are we counting this? God, man, this problem. What in the world? Why am I getting destroyed this week? So 0, 0. 0, 0. We're going to be counting this. Wait, holy Christ. Wait up. Is that why? Okay, I mean, this brute force isn't helpful then. Is that why? Is that actually why? Can that actually happen? Can that actually happen? That can actually happen, can't it? It can happen, can't it? This can happen. How would it happen? So, I mean, we need to concern with you. This can actually happen, can't it? That's absurd, man. That's absurd. That's actually absurd. How would this happen? So we have this. Okay, so this is actually not helpful at all. You're telling me that this could actually happen? I don't have a job. No, I'm still in college, but eventually YouTube will fill that role. Not this, of course. This isn't gonna pay, but other things. So this is crazy. This is J is 5 plus 1. What? Oh wait, so I mean clearly the answer here is going to be 4. 792. Oh, no, that makes no sense. Okay, never mind. This isn't gonna work. Okay, but somehow... Damn it. Somehow we have a point where... God damn. Oh, this is sad. Oh, this is so sad. This is so sad, man. Somehow we have a point where you are... 0. You are the same. Like where, man? I thought cycles couldn't happen. Are you serious, bro? To remove you, remove you, remove you, remove you. How do we deal with that? How can we possibly deal with that? Okay, so... That's interesting. What? How then? Oh, how? What? Oh, that's great. That's awesome. Now I have no idea what to do. Wait, this makes no sense though. Wait, this makes... How? How are you inserting into V yourself? How is that possible? How are you going into V yourself? Do you help here or not? How do you have 0, 0? How do you possibly have 0, 0? How? How do you have 0, 0? Is that a bug? I mean, what? Like, what, man? Seg.query II. Oh. Oh. Wait, no, wait, what? Oh, okay, okay. No drop frames. Nice. Why is this true? So confused. So confused about everything. What's going on? How? This is so weird. What is going on? Why don't I understand this? I mean, you should be this. PR V plus 1 is 1. STV plus 1 is 1. Do you? Oh. Why are so many of you the same? Oh. I see. Okay. If R mod 2 is equal to A, C mod 2 is not equal to B, okay. So we do this and it'll work, right? Yeah. Great. If we do this, well, 137. Oh, that's depressing. How do we compensate? So what are the issues? B plus 1 is 8. So you flip here, you flip here, and you move here. Can we hack this? Can we hacky fix this? When do you double count? So you're going to double count when... When do you double count? Wait. So we do this. We do this, we do this, we do this. Now, why do you double count? Oh wait, V is 7. You're saying here, 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 here. Wait, what? V is 7, I is 8. So you're saying when we're here, we're going to count 8, 7? V is 8. So we can move you here. How? Why does that happen? Where else does this happen? V is 13. 0, 13. Let's try something. What? I know that's not right. Fine. How does this work? This wouldn't work, right? No, that wouldn't work at all. Wait, what am I doing? This is stupid. So, I mean, this is invalid. So we're considering shifting you over and shifting you over. Shifting you over. Why do you have 3? Shifting you over. Shifting you over and shifting you over. Now, why do you have 3? V is 13, I is 14. Oh. Doing that lets you do this. And then this. Why is that bad? Because if we do this, then this. So we do this, then this, then this. No. Phi is 14. Do this, then this, then this. Then remove this. Then do this, then this. So V is 14. What can we reach? V is 14. We can reach 1, 3, 5. How do we reach 13? Can reach 15 or 17 or 27. So it's 14, 24, 26. Why can 14 reach 13? 14 can reach 13 because 14's here. We'd shift you this way. Shift you up. Shift you this way. Remove you. Go here. Shift you this way, and then shift you this way. So that's bad. Do work. Why do you not work? $82. Why exactly? Because you're garbage. It's not. Wait, what are you? So, I mean, the problem is we're reaching this from 14, right? Problem is we're reaching this from 14. This is perfectly innocent to be reached from 13, but not 14. So why are we reaching this from 14? We're reaching this from 14 because we're not excluding 13. What's wrong with 24? Where's 24? 24 is this. Wait, what? Remove you. Remove you. Oh. We get the same issue here. So the problem is 13 can't be added from what? Oh, God. How do we exclude 13? And similarly, the other one. How do we exclude 13? How do we exclude this? Oh my God. Okay. This sucks. So 13 is invalid because it's reachable from 14. So we're adding u in from 14. What are we adding u in from? This isn't the issue. No, this doesn't work. Okay, so we need another seg tree. It's dumb. Wait, we didn't need a segment tree at all. This is so hacky and it's not gonna work. This is really not gonna work. Let's see. Wrong answer in test 10. Let's try something else. seg2.update 1. Will this work? No. So this makes no sense. So if we do this, you'll be 133, right? No. Auto RR. So I mean, this is the issue, right? What's this code? Oh. 36. Yeah. 129. I shouldn't make the difference, but I have no idea. Why do you make the difference? Why does this not work? $75. $75, $78, $132, $133. Most of you. A is 0, B is 1. So when we have an R, we're assuming that you're being used. When we have an R, we're assuming you're being used, right? Which means if you have an L, this should not be counted. Where are you being added? To V. So 13. So 13. Why? Yeah, this assumes... What does it assume? Well, only if we use you. Right. So what if we... Okay, let's try this. Seg.update en1 stv minus 1 env minus 1 negative 1. You break everything? Yes, you break everything. Okay, so we're gonna forget about you. Yeah. This is annoying. So, I mean, when we have... So, I mean, it's 13 we want, right? So we have 13 here. Then we can move you here, we can move you here. We can move you here. But what we're doing is... we're counting this, and then we're removing this. Even though we're not actually using this. Counting this, then we're removing this. Even though we're not actually using this. Removing everything that this might use. I mean, so the... Okay, I mean, let's find a break case, right? LR, UL, U, DLRD, UUDD, right? This says 58. Brute force says 56. Okay. Yes, so we are overcounting still. And the problem is we want to... We need to remove this. But in an unassuming way. So we have this L here. So why is this bad again? Because we count this R. We're going to do this. 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 Then we're going to do this. No. So you need to be here, but then you undercount too much. Why do we undercount too much? Because here, at 13, we start... So you get 133, right? R is 2, C is 1. So here at 13, R is 0, C is 3. All right. You move this. But here, then we add all this back. So this needs to say if we use this, what the hell? So trippy. This needs to say if we use this, then this doesn't work. If we use this one, then this doesn't work. So then we need to say, well, if we start using this, then none of this subtree will work. But if we have a way of getting you so we need to nullify this subtree, right? If we use you, then none of you will work. But what if we have a way of reaching you even before this? If we use you, then none of you will work. But what if we have a way of reaching you before this? Well, then we're going to use this anyway. So we need to nullify you. Okay. Okay. So we need we need to write a special segment tree. To write a special segment tree. So it says, if we encounter you, we get this whole subtree. If we encounter you, we have to block out this entire subtree. So we need a segment tree that stores the information we do at each update. And then this is crazy. This is crazy. Okay, let's just make sure this actually works, right? So UU DD ULRU D UU DD. What are you? 516. $871. Let's see what the brute force says. Okay, and let's if local you. Wait, are you actually 16? 1, 2. Oh wait, vector. Why? Why? Oh, that's why. 80. Seg fault. Why seg fault? Are you valid tiling? LR U okay, let's UUDD LR, yeah. LR, LR, UD, 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 LR, UD, LR, LR, UD, UD. There we go. UD, UD, LR, 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 UD, LR, UD, LR, LR. Okay. 710. 700. Okay, sure. Um, 240, 240. Okay, can we please, like... Where? Where am I PR? Okay, good. Now, let's do this. TRI is equal to 1. 4 LI is ST. VLSV. VLTR is SV. Hmm. 570? What? 3570. Are you kidding me? I'm not printing this. What? No, wait. $36.54. Do you work on this? Yeah. What in the hell? This makes no sense. Well, so I mean, but you want me to be different. R is 1, C is 1. Alright, but then you hit the cycle issue. Why does this not work? Oh. And what? R mob. Okay. Now we try you. So we're still double counting after all this? Yes, we are. Still double counting. Yeah, I mean, that works. But how do I not double count? Chipotle. I don't know what to do about this. This is really unfortunate. Which one are you? What? Wait, what? What? Oh, it's inverted. Ah, shoot. Okay. 4 car C auto V G 4 car C B C S. Yeah, sure. TT is 793. R is 14. C is 3. R is 14, C is 3. R is 10, C is 6. What? Yeah, it's convenient, isn't it? Makes life so much easier. Unfortunately, it's not saving me in this problem, but it does make life easier. So what in the world? So LR, right? So we can move you up, move you up, move you up, move you up. So we can move you up, move you over, move you up, move you over, move you up, move you over. Why are you counting this? So we can remove you, right? We can move you here, move you here. Move you here, move you here, move you here, move you here, move you here. Okay. Or we could remove this. By what? We can remove this, move you here, move you here, move you here, move you here. You're a cycle. Ah. Cycles exist. Cycles exist. I'm going to cry. This is so sad. I might actually be just beaten by this problem. I have I don't know what to say for it, man. This is actually crazy. This isn't invalid though, it's just a cycle. I mean, it's not a cycle of the same parity, but it's a cycle of different parities, which does work. So we're gonna move you, move you, move you, move you, move you. This is wild. And then there could be more here. Wait, how does this work? Move you. Move you. Move you. Move you. Move you. How does this work? Move you down. Move you down. That doesn't work. Move you down. Move you down. Move you, move you. Move you. Move you. Move you, move you, move you. Move you. Then it stops working. Well, where the hell is this cycle? So, I mean, we remove this. This is clear. This. If we remove this, or we can not remove this. We could do this, do this, do this, do this, do this, do this. Let me get the same issue. Let's try something. LR. What? Are you invalid? Oh, yes, you are invalid. I can't just do that. Very confused by how this cycle exists. So we can remove you. Remove you. No. So we remove you, right? Then there's exactly one move we can do, and it's this. Move this down. Move this down. Move this over. Move this over. Then we move this over. Then we move this over. Okay, I see. I mean, yeah, that's valid. And this is reachable from this. This is crazy. This is insane. So there's some that are invalid, and then there are some that are just crazy. Did I just do that? Yes. So you make this worse. So far, none. Depends on the stream, though. The apple is fine. That's not my concern. So anything that feeds into a cycle is bad, right? Anything that feeds into anything that feeds into anything that feeds into a cycle is bad. Wait, what? Wait. ULR. Wait, what exactly is bad? God, man. Okay. So if we remove LR, right? Then you also become part of the cycle. So, okay, we can have cycles, fine. They're going to be ends, that's fine. We can't just count cycles. That's not how that works. I mean, it is kind of a functional graph, right? No, it is a functional graph, yeah. How does this work? How does this work? Oh, most of the time it launches you off the graph. It's LU, LU, RU. So if we have a node that doesn't launch you off the graph, right? But like, then what? So each cycle is 1. How does this amount to 5? So I have a semi-functional graph. So I mean, it's a matching between the two L's. No, it's not. The L matches to the R. The L matches to the R. So I don't understand how... ULRL, right? Then D... That is 21. It doesn't matter, but... Do you matter? Wait. Are you 21? No, you're 20. Wait, what? Alright, okay. Yeah. So you launch into this, and so do you. But then so do you, and so do you, and so do you, and so do you. Now this makes no sense. We have a functional graph. Hi, I'm doing great. I'm considering giving up on this one. Just because it's driving me crazy. We have a functional graph. I know I don't like to give up often. This one is special. I don't know. I just cannot get anywhere on it, pretty much. So why does it count extra to have us feed into the cycle? Why does it sometimes count extra? Why is it sometimes not? Is it the LRs that feed into the cycle? That'd be wacky. Not because of problem difficulty at all, yeah. And it's like 3,200. You could probably do it at your prime. Given infinite time. If we figure out the cycle thing, life will get easier. How does that work? What makes us repeat cycles? Oh, wait. Wait, what? Yeah, if you only do them given infinite time, that's fine. Then it will work. So you overcount by 2. Which confuses me. If we do this, you overcount by 1. Which confuses me further. We do this. We overcome by 3? No, seg fault. Why don't we use seg fault? Because I don't know how to type, that's why. Why do you overcount by 2? Can't make sense of this. This doesn't make sense. I don't understand this. I think I'm going to submit this and then leave it as is for now. Maybe I'll come back to it when I'm smarter. Right now this is not working. Let's just submit this code to have it as an archive and then be done. I mean, if we could figure out how to count the configurations that happen twice, then this would be fine, right? Okay. Give on that. I don't know, man. How do we count the configurations that happen twice? So if we have some cycle, if we have a cycle, that's 1, right? If we have a cycle, that's 1. What else appears twice? Oh, I forgot we could do this. We have this tool. Well, it's not a functional graph. Oh, what are you saying, dude? It's not a functional graph. It's a weird graph. Right. Because everything has 2 edges. It's the union of 2 functional graphs. And the graph is weird. So what the hell happens here? Oh. Okay. Most edges launch us off the graph. I mean, the directedness matters. The directedness matters, right? Has to follow these directed edges. go until a point, then switch and go back and then switch again. And then any note that reaches this. Are there multiple ways to cycle? No, right? No, there cannot possibly be multiple ways to cycle. Because this has exactly one path out. So we need to know if there are multiple ways to cycle. How do we know if there are multiple ways to cycle? Right? If there are multiple ways to cycle, there can't be. You just need to find any cycle, right? If you cycle to U, there can't be cycles in the same parity, but there can be cycles in different parities. There can be cycles in different parities. You can figure out the overcounting. And this would be fine. There can be a lot of such pairs. There can be a lot of pairs that feed into you. And this directly reaches you. Where's 16.3? How do we do this? Given this strange graph, if we consider this, right? U, 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 U. U, 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 U. So you're eventually gonna fall off the graph because you have no other choice. We're gonna form a tree structure. You're eventually gonna fall off a graph and we're gonna form a tree structure. And what do we do with this tree, man? cycles. So the cycles are what's broken with my solution. Let's change. Not much, huh? Okay, I'm gonna call it here. This is a shame, but I don't know how to do this better. Difficult area? 32. Yeah. Okay, I'm gonna call it. Something about cycles, man. If we could find cycles quick enough, that may be enough to solve it, but whatever. Slide a VCA div 2, I guess. Can do that. Why not? Look this one? Yes. Look at this one. We have not. Yes, we have. Rebranding, right? Look at this one. No. Okay, sure. Yeah. Now we're gonna have to clear this code. Probably gonna have multi-tests. Okay. Wait. Hang on. That's not it, right? I just want to see how big the test is. Yeah, no, okay. Alright, let's have a break from that. Okay, Jesus. And this week has been fun. So we got destroyed by a 3300 that took us the entire day. Then we spent the entire day on a 3200 that we didn't solve. Great. Ups and downs, ups and downs. Not much to say about it. Stuff. This countdown is forever. This is lasting forever. Alright, hopefully this is a more fun round than last time. I don't know. 1 and 2. Okay. C and N. C and AI. S minus equals AI minus 1. If S is equal to K minus S, C on I plus 1. Turn. Okay. Well, that's okay. C into N, C into AI, S plus equals AI minus 1. K is S. Minus equals, yes. Sure, be that way. Sum of digits is none, yes. X plus Y is N. The sum of digits of X and the sum of digits of Y differ by at most 1. You gonna work? Okay. Alright, so I mean, yes. LA is 0, B is 0. Bool F is equal to 0. While 1. N is greater than 0. So go to N over 10. And A plus equals D times R over 2. B b plus equals d times r over 2. If r mod 2 is 1, okay. 33, 34, 103, 103, 14, 5, 130, 31. Yeah. C into n, bool f is 0, d is 1, y is greater than 0. Yeah, sure. Matching numbers. Each sum of matched pairs is consecutive and distinct. Thank you. Each sum of matched pairs is consecutive and distinct. What the hell? Okay, C into n. Hello. So we have 2n times 2n, so we have n times 2n plus 1 over 2. So we have 2n times 2n plus 1 over 2. A is 1. Okay, what the hell? So 6, right? So that's 21. So we need 3. So we need 2n plus 1 mod n is 0. What? No. Wait, what? Wait, it's always divisible by n. Right, so we have 4, so we have 8. So we have 4 times 9 over 2, 36. Right? 21, 28, 36, yeah. No, but we need... Okay, so you're divisible by n. So we need n times n minus 1 over 2 to be divisible by n. So we need n to be odd. If n is odd, does that suffice? N times... Okay, how do we pair? N is 1, k is 3. Do you have a formula? Oh, it's 7n. No, it's what? It's 3 times n over 2. 3 times CL n over 2. Why? Okay. So for 5 and 9, right? Wait, what? Oh, it's 2n. it's up to 2n. Okay, yes. How does this work? Okay, jump. Jump back 1, jump forward 1, right? Oh, wait, what? Okay, start with what? If we have 5. Ah, this is annoying. How does this work? Consecutive and distinct. 1, 2, 3, 4, right? So if we have 5, what do we pair 10 with? Let's pair 10 with 3. So k equals 9 to 13. So pair 10 with 3. Pair k equals 12. So 18. So pair 14 with 4. And then down to 11. Then we pair 10 with what? 7. We pair 9 with 6. We pair 8 with 5. And that works. Okay, sure. That's dumb. Okay, so VL all. Vector PL V. Res. For LM is equal to M plus 1 over 2. For LI is 0, I is less than M. Res dot push back N minus I M minus I. Res dot push back. So what do you know? So M minus 1. Res dot push back what? So your N minus M minus I. Work. I just need to know. Okay. What? Oh wait, it's 2 times 2 times no. 625143. That works. 10375. Okay. sure. Moving dots. Play a game with n dots on a number line. Initial coordinate of the ith dot is xi. These coordinates are distinct. Every dart starts moving simultaneously at the same constant speed. Each dot moves in the direction of the closest dot until it meets another dot. Okay, thank you. In the case of a tie, it goes to the left. Two dots meet if they're in the same coordinate. After that, they stop moving. The result of a game is the number of distinct coordinates where the dots stop. Results when we play the game for every subset of the given n dots that has at least two dots. One, two, four, six. Okay, what? Subset of size 2. How does this work? This game is too easy. Calculate the sum results when we play the game for every subset has at least two dots. And it's 3,000. So I mean, gaps. Let's count gaps. Two dots will form a gap if two dots will form a gap mod up 29 mod two dots will form a gap if PV0 is 1 for really couldn't give a big sample, huh? You just couldn't. We count gaps. So So the tie rate matters here. Okay, so a tie goes to the left. So for I is 0, I is less than n, I plus plus. LL, L, n minus 1 minus j, right? Why? What? Wait. What the hell did I do? So for j is I plus 2, j is less than n, j plus plus. N minus 1 minus j. Yes. Now, for j is I plus 1, j is less than n, j plus plus, while ls is greater than or equal to 0, and you're too close. So AI minus ALS. AI minus ALS. No, it's not LS, it's AL. So if you're too close, so if you're going to go to the left, is strictly less than AJ minus AI. LS is equal to LS minus PBL plus mod. AJ minus AI. And AR minus AJ. case of a tie, we go to the left. So if you're equal, we're going to go to the left. RS equal to RS minus PV n minus 1 minus R plus mod. 29. I is 0, J is 1. That was -1, R is 2. Wait, what? Oh, wait. Wait, crap. Well, L is greater than or equal to 0. And AI minus AL is less than AJ minus AI. Now you're good, right? Yeah. Okay. C into N. PV0 is 1. Yeah. C into AI. Ants is M power 2N. Ants minus N plus minus 1 plus mod. I is 0 up to N. L is I minus 1. Ls is 0. Yeah. J is I plus 1. J is less than N. J plus plus. Well, L is greater than or equal to 0. And this is going to break the tie. Move you. Well, R is greater than N, and you're going to break the tie. Plus plus R. PL minus LS times PR minus RS. Okay. Sum over 0. Consider S a set of segments satisfying the following conditions. Each element of S should be in form X, Y. There's so many places to get wrong here. Okay, good. The hell? Okay, sure. Alright, we're doing not bad then. You're given an array A1 to AN of n integers. Consider S a set of segments satisfying the following conditions. So we count go over U, and then we go over U. Contribution to sum. Yeah. Okay. Given an array A1 to AN of n integers, consider S a set of segments. Sum of the lengths of every element in S. Given an array A1 to AN of n integers, consider S as a set of segments satisfying the following conditions. Is greater than or equal to 0. Oh, seriously? It's freaking optimal partition all over again. So if we take something, then this is dumb. So we count the number of segments. Count the number of gaps. We have you. Contribution to sum. The number of points where you move left and you move right. Move in the same direction. Yeah, okay. Okay, so const L max equal to -189. Seg tree max t st VL PS. For I0 is less than M. AI is equal to negative max. S LV S equal to lower bound ps.begin, ps.end, s. st.query, ss. V is max vx. Why do you not work? No, v st.update ss v minus x. Okay. For I0, I less than I plus plus. PVI. Opt 0 0. Okay. st.query s m minus 1 dot val plus I plus 1. Opt PVI R minus I plus 1. What? What do you mean? How? BI is, oh. That's why. 10. What the hell? Okay, s equals 3. Oh wait, 0s, right? There we go. Okay, this is a problem. VLPS C into N, VLAN, PVN, R is 0. PVI is R. PVI is negative max. Opt is SV. LX st.query ss.val. V is max VX. So update SS V minus X. Yeah. Opt 0 0. S is PVI. S is lower bound ps.begin, ps.end S minus ps.begin. R is st.query 0s.val plus I plus 1. So here's the issue. 5 negative 1 1 negative 100 1 1. You're gonna be like 2 or something, right? Yeah. So R is max R ants. And suddenly everything works. st.query 0s.val plus I plus 1. R is max R ants. And then that involves us typing nothing. Okay. Suddenly this would seem to work. XOR tree and queries. Given a tree of n vertices, the vertices are numbered from 1 to n. You'll need to assign a weight to each edge. The bitwise XOR of all edges on the shortest path from U to V should be x. You gonna work? Okay. Cool. The bitwise XOR of all edges on the shortest path from U to V should be X. The hell? How do you, what? Oh, are there people who are just solving? Okay, whatever. Alright, sure, this is dumb. What a problem, man, what a problem. XOR tree inquiries. You're given a tree of n vertices. Vertices are numbered from 1 to n. Be AI. The weight of each edge should be an integer between 0 and 2 to the 30 minus 1 inclusive. Print a solution so that the total XOR is the smallest. To minimize the total XOR. Be AI. The shortest path from U to V should be X. Find out if there exist weights of each edges. Print a solution so that the total XOR is the smallest. Great. This is freaking, I don't know, that problem again. 2.5 times 10 to the 5th. Okay, so bit by bit, that makes life easier. Because bits are independent, of course. Now we have to solve a certain number of problems. Okay, bit by bit. Now, XOR is sum of XOR to the root. So this puts a constraint that okay, so this puts a constraint that that the XOR sum from this node up to the root must be either the same or the opposite as the other one. If this graph is bipartite, is it always possible? That is our question. If this graph is bipartite, is it always possible? Which should be, right? It should be, right? Because let's say you're going to be 0. Why is it not always 0? That is curious. Oh, well, yes. Wait, what? Yeah. Wait, what am I saying? Okay, so if we have any component, all right, so we assign you arbitrarily, right? Then the edges are easy. Then we assign you arbitrarily. We do bipartite check. The edges are easy. Then we don't even need LCA. Then if there is a component with a different parity of ones and zeros, then flip it. Otherwise, don't flip it. And then that's it. And this problem is done. And Jangly won the round already. Jesus Christ. This is a div 2, huh? Okay, sure. So all right, so C end Q, VL edge, max, so weight max, map PL LO and P. For LI 0 is less than -1. VL edge max. C and X Y minus X minus Y X greater than Y swap XY lab XY is equal to I. Edge X dot push back Y. Edge Y dot push back X. Now for vector array L3 QV. Okay, vector PL for L B is 0, B is less than 30, B plus plus. For Li 0 is less than Ni plus plus. Bip I dot clear. Call I 0. Vector Bulvis max. Bip I dot clear. This I is 0. For auto XYZ QB. And There's a special case for the component with 0 in it, which is kind of annoying, actually. The component with 0 in it must always have the color of 0 be 0, which is fine in how we're going to construct it, but yeah. So if, yeah, then this distance to the root must be, okay, sure. Okay, that's fine. Auto XYZ QV, LO, W equals Z, shift B and 1. BIP X dot push back YW, BIP Y dot push back XW. Okay. For I 0, I is less than N. If not this I, DFS I 0. Void DFS VLC. This V is 1. For auto XW edge BIP V. If this X, if call X is not equal to T, can is equal to 0. Else call X is equal to T. Else DFS XT. Comp is equal to vector VL. Comp C. Comps I0 dot size mod 2 is not equal to comps I1 . Okay, now auto comps. No, we didn't even need that. Yeah, no, we do. For T is 0, T is less than 2, T plus plus. For auto X, comp T, call X is T. D weight 0, 2 to the B. Void D weight. If P is not equal to -1, weight V plus equals weight call V XOR call P times W. For X edge V, if X is not equal to P, D weight X VW. VL res -1. P is equal to var v is p. Res lab rp is equal to weight I. Okay. Did I do it twice? Yeah. I'm confused. I pasted my code for E. Okay. No. Okay, let's see if you actually work. Second example, the two given conditions are A1. Okay, we need to graph editor. So 5, right? So your XOR is 5. And your XOR is 3 XOR 5, which is, so 101, so 6, right? So that's 6, 1, 4, 3. Wait, what? Oh, wait, no, that's fine. That's fine. 6, 6, 3, 6, 5. Yeah, that's 0. Okay, perfect. Okay, so do you actually work? Yeah, thank you. So we have 1 and 4, which must be 2. 1, 2, 2, 3, 3, 4. So you must be 2. That's true. And then 2, 5, 5, 6. So 4, 5 must be 7. Yes. And as for you, yeah, the same thing. 1, 4, 3. 6, 6, 3. 1, 5, 7. 1, 6, 5. So that's 6, 6, right? 6, 6, 5. Okay, perfect. So you work on samples. Scene to n to q, n minus 1, scene to x to y, lab x, y is I, vector array LL3QV, sure. For I is less 0 up to n, bit by dot clear, call I is 0, vis I is 0, auto x, y, z, qv, wz, shift b and 1. Yeah, so call I is 0, vis I is 0. LL1 is 0. For I is 0 up to n, if not vis I, dfs I 0, 1 plus equals comp 1 dot size, comps dot pushback comp. DFS, right? Vis v is 1, call v is c, comp c dot pushback v. For auto, for each edge, yeah, vis x, yeah. Okay, sure. So for everything excluding comp 0, because comps 0 must have 0. Comps I 0 dot size mod 2 is not equal to comps I 1 dot size mod 2. Swap and then break. For auto comp comps, call x is t. D weight 0, negative 1, 2 to the b. Yeah. Then we are as n minus 1. R is greater than p. Yeah. Comps I 0 dot size mod 2 is not equal to comps I 1 dot size mod 2. Swap and then break. Yeah. Okay. Here we go. Okay. Work. You gonna work or what? Time limit exceeded. Time limit exceeded on test 8. Why TLE? What? Vis V is 1, col V is C, comp C dot pushback V. Do you like, how fast are you? X is equal to I plus 1. Y is RNG mod I plus 1. $33.06. You fine? 29.32. That's not fast enough. Can you make it faster? Come on, man. Pragmas. Let's go. Shouldn't make it that much faster, right? No, that makes it slower. Okay, this is fine. No, it's not fine. Okay, let's do this. T col plus equals T shift B. Void D weight. Weight V is T col V XOR T col P. You still work, right? Yeah. Alright, now you should be much faster. Yes. Okay. Oh, that's dumb. Why does that have to be a thing? Wrong answer on test 33. Bro. Okay, C into N to Q. For I is 0 up to n minus 1, I plus plus, C into x to y, minus minus x minus minus y. If x is greater than y, swap x, y. Lab x, y is I. Vector array LL3 QV. C into x to y to z, minus minus x minus minus y. Q dot push back x, y, z. B is 0 up to 30, B plus plus. Clear, call I 0, bis I is 0. For auto x, y, z, q, v, w is z shift b and 1. Bip x. So, doesn't actually matter what the root is. Okay, void dnet lv lp. Dnet. You serious, bro? I is 0 up to n, I plus plus. If not vis I, comp is array VL2. Okay, no, right, that wouldn't work. Are you serious? This is annoying. If 1 mod 2 is 1. Okay, yeah. So we need to root you out a node. Oh. Yeah, we need to root you at a node with an even component size. Damn, man. This is really annoying. DSU D dot merge XY. R is 0. For if D dot sizes D dot marks I, mod 2 is equal to 1, R is equal to I. Yeah, if your D dot sizes D dot marks I, this is so sus. DSU D dot init N. Vector array LL3 QV. I is 0 to Q. D dot merge XY. LR is 0. So if D dot sizes, D dot marks I, mod 2 is 0, R is I. VL seek. For LI 0, I is less than I plus plus seek dot push back R plus I mod N. I seek. Not this I. Auto XYZ QV. Oh, I seek, not this I. What? How does this work? So you still work. understand. It's degrees, isn't it? It's degrees. It's freaking degrees. Oh my god. VL size N. For Li0 is now plus size d dot marks I. Is one laptop better die? No. Plus equals add I dot size. Okay, I see. Now you're odd, right? Yeah. Okay, I understand. Size. I0 size X mod 2 the hell? Wait, what in the world? Okay, so you're not gonna change. I is 1, 7. Got it. Okay, that explains a lot. So you're gonna die on me now? Yeah, you're slower. No. It's like, what's slow about you? Sure. Is this faster? Okay. Yeah, this is so dumb. What in the world, man? Great. let's just get rid of comp. If one mod 2 if size p mod 2 is equal to 1 and p is not equal to d dot marks r, d dot marks j is equal to p, call jx or equals 1. Break. Just gonna get rid of comps. And you're gonna work. For I0 I is n t call I plus equals call I shift b. Okay. Okay. Size p mod 2 is 1 and p is not equal to d dot marks r. Call jx or equals 1. Yes. Alright, well, hopefully you work. Again? What? What? Scene to end to q. I0 to -1. Scene to xy -x -y. Lab xy is I. Vector array LL3 QV. I0 up to q, I plus plus. Scene to xyz. Minus x, minus y. D dot merge xy. QV dot pushback xyz. R is 0. VL size n. I0 up to n. Size d dot marks I plus equals adj I dot size. PR size. For I0 up to n, if size d dot marks I mod 2 is 0, R is I. VL seek. I0 up to n, seek dot pushback, R plus I mod n. Wait, no, wait. Oh. God, okay. I'm just an idiot. So like for I0 up to n, right? OP is d dot marks I. If size p mod 2 is 1. Okay, so we're saying this all has one component, right? So the entire graph is connected. For I0 up to n, if if size p mod 2 is 1, and either p is not equal... Okay, holy Christ. Size p mod 2 is 1, and if size p mod 2 is 1, and col p is equal to 0, is equal to 1, d dot mark, and col I is 1, d dot marks j, r is equal to I. D weight R negative 1. Holy Christ. D init 0, 0, 0. Dep v is D. Dep p is greater than dep v. T is equal to p. Wait, T. Call. Okay, that works fine. Bit.clear. P is d dot mark I. Size p mod 2 is 1 and col I is 1. R is I. For j is 0 up to n, d dot marks j is p. Call j x or equals 1. T is v. If dep p is greater than dep v, t is p. Weight t plus equals col v xor col p times w. All x adj v. So why are you so much slower? Holy Christ. Okay, that's great. This is so annoying. Q. If P is not equal to -1, wait. Well, T is V. Co V XOR co P, shift B. So incredibly annoying, man. Y is not equal to T, can these still work? This is moderately annoying. What is the bottleneck? Bro, I swear to God. It's like, it's the balance between having to write this for time and having to write this for correctness. Still? How? How? I don't understand. I is 0 up to n minus 1, I plus plus, c into x to y, minus minus x, minus minus y. If x is greater than y, swap x, y. Lab x, y is I. Edge x dot pushback y, edge y dot pushback x. D init 0, -1, 0. DSU D, D dot init n. Vector array LL3 QV. So I mean the cost of flipping you. Oh, wait. If col I 1 plus equals adj I dot size. That is true. Damn. Somehow this is still wrong. Somehow this is still wrong. Somehow this is still wrong. I don't understand how this is still wrong. C into XYZ, D dot merge XY, QV dot pushback XYZ. Dot size. L of B is 0, B is less than 30, B plus plus. I is 0 up to n. If not visited I. Q L O Q. Q dot push I. This I is 1. While not Q dot empty, all X is Q dot front, Q dot pop. For auto Y 0 bit X, T is col X, X or W. If visited Y, col Y is not equal to T, can is 0. Otherwise, col Y is T, Q dot push Y, this Y is 1. For each node, if col I 1 plus equals adj I dot size. 1 mod 2 is 1. If size P mod 2 is 1, and col I is 1, if size P mod 2 is 1, and col I is 1, R is I. For J is 0 up to n, D dot marks J is P, col J XOR equals 1. Break. QPLQ. Memset col 0 size of col. Memset vis 0 size of vis. I can't even add asserts because it's going to TLE, dude. I can't freaking add asserts. For I 0 up to n, if col I 1 plus equals adj I dot size. Well, R is 0. If 1 mod 2 is 1, 1 plus equals adj I dot size. Right? That's what we need to do, right? If you're labeled as 1, you're going to flip all of these. If you're labeled as 1, you're going to flip all of these. If 1 mod 2 is 1, right? I 0 up to n. Size P mod 2 is 1. And col I is 1. R is I. For all J is 0. Depth P is greater than depth V. T is P. Make T plus equals col V XOR col P. I I is 1, I is less than I plus plus. All R is IP. For LX edge I, if dep X is less than dep I, P is X. PRIP. I'm so confused. I'm so confused, man. Q, P, L, Q. Q dot push, R negative 1. While not Q dot empty. Auto VP is Q dot front. Q dot pop. P is not equal to negative 1. T is V. Col V, XOR col P, shift B. R is 0. If 1 mod 2 is 1, that means we have at least 1, 1. I is 0 up to n. P is D dot marks I. So if flipping this component, we'll flip all of you, and col I is 1. R is I. LJ is 0 up to n. D dot marks J is P. Flip it. Call J XOR equals 1. I'm so lost. I'm so lost. Def V is D. For LX edge V, yeah. So when we got rid of this, I is 0 up to n minus 1. D init 0, negative 1, 0. DSUD, D dot init, D dot merge XY, QV dot pushback XYZ, VL size N. Size D dot marks I plus equals adj I dot size. So flipping you is going to flip every edge, right? And you have to be the same color. If you have to be different colors, then flipping you is going to flip every edge. B is 0 up to 30. Memset col 0, size of col. W is Z shift B and 1. Pushback Y W. Y dot pushback XW. Not visited I. YW pipx. Visited Y. If color Y is not equal to T, can is 0. Co Y is T. Q dot push Y. Visited Y is 1. I is 0 up to n. If col I 1 plus equals adj I dot size. R is 0. If 1 mod 2 is 1, I is 0 up to n. Size P mod 2 is 1. And color I is 1. And the color of I is 1. R is I. D dot marks J is P. Col J XOR equals 1. Q dot push R negative 1. While not Q dot empty. P is not equal to -1. LT is V. If depth P is greater than depth V, T is P. Depth P is greater than depth V, T is P. LX edge V. PRI T call I. Not can. For LX agi, dep X is less than dep I, P is X. Well, R is I, P. Lab RP is weight I. LX res. So, the number of odd edges is going to be the degree, right? It's going to be the sum of degrees. You have 0, 0. If we have any component, if the sum of degrees of all components are even, there's nothing we can do. The sum of degrees of all components are odd. Wow, this problem, huh? I0 up to n. R is 0. If 1 mod 2 is 1. I0 up to n. I don't understand. Awesome, man. Awesome. Why are you 250,000? Should make life easier. This is so insane. Oh my god, man. That was fun. That was so fun. Oh my god, dude. Okay, well, that was great. My god, it wasn't hard. It wasn't hard. Just Jesus. That was fun. That was fun. I was ready to pull out more optimizations. Why? I guess you're not supposed to do log? I don't know. I don't know, man. Like it really shouldn't be that slow. I don't understand. Okay. Whatever. QS is less than QE. QQ, QE plus plus. Okay, once this is over, I'm gonna run it again. Okay, cool. So that was fun. And then you finish it off by, I mean, it's 30n. It's frickin' n log n. It's frickin' n log. That's crazy. That's actually crazy. Recursion is the bottleneck for that. That's crazy. I have no idea. Depends on the operations. I mean, it varies from 1e8 to 1e9. Here, apparently, it is very small, which is really cool. How fast is this? Is this faster? This should make life easier, right? Like, it should be moderately faster. Okay, it's like not that much faster. How are you not that much faster? Jesus, dude. Jesus, man. Oh my god. Literally, what, top 5 with A, B, C, D, E, and then this? That's crazy, bro. That's actually crazy. What is test 74? So test 33 is it's a test where you have to, yeah. You're probably a system test, right? No, it's pre-test 33, yeah. It's like test 33 is a test where you have to be very careful with the ones and zeros. Like if you, oh my god, if you, I don't know, man. I guess there's an easier solution. I don't know. I mean, this one is pretty straightforward, I would say. I guess could you do it all at once? I guess you could, right? I guess you could do it in one. I don't know, man. You could do it in one. Like, you could do it in one. You could. You could do it in one. I just, like... Bro. I don't know, man. So I mean, if you find the weights, yeah, then the root needs to be 0. The rest are fine. So if the root is 0, as long as the root is 0, as long as you have something with component size 0, bro, that's actually crazy. That's so crazy, dude. How the hell did we do so badly at the end? My god. TLE, right? Why? Okay. This is very dumb. You're all no tests. Okay, so tests 4 to 7 are useless, and then test 8 is just big. I don't understand. I have fast I/O, right? Like, yeah. I don't get it. I don't get it. I don't get it. I do not get it. Somehow this is too big. 30, I guess DFS. I guess graph traversal is very slow in general. Still, though. So you could, in theory, like... I mean, you have to root the tree, don't you? Like, you have to root it at something that becomes 0. You have to root the tree... have to root the tree such that the root has color 0 for at least that node, for at least that bit. I mean, something's gonna have color 0. If everything has color 0, then 1 is not 1. Something has to be color 0. Man, that's crazy. Okay, stupid. Very stupid. Very, very stupid. 2500 something, whatever. DFS and similar. DSU, graphs, greedy, implementation, trees, yeah. It's a lot of tags. I don't know. I don't have anything to say. That was really dumb. Where are we now? Global round 8, right? Is this one impossible? No, it's doable. Probably not going to solve it today, but we'll look at it. Johnny has a new toy. He's made guess. It's a little bit extraordinary. The toy is a permutation P of numbers from 1 to n. Toy is a permutation P of numbers from 1 to n written in one row next to each other. For each I from 1 to n minus 1, there's a weight Wi. And those weights form a permutation. Minimum number of inversions. So for any given segment, I'm not going to solve this tonight, but we'll just look at it. According to LM and M plus 1 R and swap the two parts. Warp and size C before one. Move the chosen subsegment. So WM stays. PM plus 1 to PR moves. PL to PM moves. So consider the 1. No segment will contain the 1. So the probability that a segment of length n exists is 1 over n squared, which could happen. So I mean, for any good segment, you can be changed, you can be done interchangeably. So I mean, the expected number of good segments is not that big. Further, the expected depth is not that tall. So all we need to do is maintain this, right? Oh wait, we can. Oh, okay. I understand. So the ends are zeros, which means that we can do a move on the whole permutation. We can do a move on the whole permutation and 1, and we can swap those two. And then for everything in between the whole permutation and 1, so 1's going to be roughly near the middle, which means that then we RMQ. We build the Cartesian tree, something, on the weights. Okay, this is stupid. Why? What is the point of this problem? I guess we should code it, but are you gonna be 33 or 32? I don't know, man. Do you have any more souls? As you may guess, it's a little bit extraordinary. Towards a permutation P of numbers from 1 to n written in one row next to each other. For each I between pi and pi plus. Yeah, so basically, we have this tree that we're given, and I can put, oh my god, 15-second time limit, by the way, just noting that. So we can actually like do unite. We can do everything naively just because of the randomness, which is nice. So we essentially build this tree, and then for anything on U, we'll have this many inversions or this many inversions. And so we can swap between one, we can swap the stuff in between the 1, and then we look for the RMQ on U and the RMQ on U, and then we, yeah. Okay, are you 33 or 32? If you're 32, I'm not gonna code you. 33. All right, we'll code you tomorrow. I guess we'll do that. Why not? This isn't that hard. I think it's just sort of implementy, I suppose. Let's do C, because then we'll AK another. Then we'll full solve another div 1. This is a new channel. Sort of. Yeah, it's dedicated to these. It's just for this series of streams that I'm doing. Man. We really like Deg I is 1, right? So if you have Deg I as 1, size V is 1, right? have some color 0 outside of here, then this works. If you have some color 0 outside of here, if this has all of the color 0s, right? If this has all of the color 0s and this has odd degree, then there's something else with color 1s that has odd degree. Size B mod 2 is 1. Size V mod 2 is 1. Right, if size V mod 2 is 1, right? Because the sum of degrees is even. Wait, hang on. What happened here? Kind of confused by this. Oh, right. Okay, yeah. If you're all the zeros, if size P mod 2 is 1, and color I is 1, otherwise everything in U has color 0. Wait, what? Assume that not everything has 0. Which means that if this is the first component, we have two components, one with, both with odd degrees. One of them has, no, everything has at least 1 0. Every component has at least 1 0. By construction. Yeah, so this is fine. I'm just confused. I'm just very confused. Okay. Beautiful necklace, do it yourself. Beauty of a connection. Merge two pearls into one. Beauty of a connection of pearls in colors U and V. and the ith line. 2i minus 1 and 2i respectively. Wait, what? Next is part of the chain connecting two pearls. Color of each pearl can be defined by a non-negative integer. So we combine U. So we do U. We take an edge. Okay, I see. Yeah, so we need to see if A, you're connected. Mod 2 to the 1. Right. We put all of you in here. We put all of you in buckets. How exactly do we construct this? So we need the list of edges. We need the list of nodes as well. Like alternating edges and nodes. right? Maybe some Euler torus stuff. If you're connected, yeah. Right, so okay, but I need you to be big, right? What the hell? Sure, I see. This is strange, but whatever. Vector. Okay, so How does this work? Okay, I see. So need n ends, right? Edge nodes x dot out dot pushback y over 2. For x size f plus equals x. If f pos equals 0. If pos f continue. Walk is equal to Euler walk nodes n if size I is greater than 0, source is equal to I. Safe fault. Nice. Okay. Why? So you're all odd. what? Yeah. Okay. Source is 5. What? Okay. For auto x nodes pr x dot else. PO iterator ITs. For auto and nodes, ITs dot pushback n dot outs dot begin. While not s dot empty. So 5 5 0 5 5 3. Okay, I mean 5, right? While IT is not equal to end. S dot pushback IT first. EU IT second is true. This is 5. What do you mean 0? Why do I have to debug this? Why do I have to debug this template? So n edges is n. I'm so confused. nodes. So we're at 5. Nodes x dot out. Star ITSX. Why? -2. Auto end nodes. Why? Am I using this wrong? I don't understand. X is 5. Nodes x dot out is 3032. What? Why does that fix it? Why does that fix it? Okay. I don't understand why that fixes it. Like, that's literally the exact same code. I don't understand why that fixes it. This is the exact same code, right? Trav and nodes. Oh. Ugh. Okay, whatever. This is stupid. I don't care. Let's actually, I kind of do care. 4. Let's make you V, right? No, you still break. Ah. No. Okay, I don't know what Trav is, but I understand why that fixes it now. Oh, wait. You should be fine, right? Yeah, okay. So you have to be a reference, otherwise it makes it, yeah, okay, that makes sense. That makes sense, sure. Okay, now we just have to construct the thing. So for li map PL VL set L. MP XY dot insert I MP YX dot insert I. Vector MP walk XY dot begin MP XY dot erase P MP YX dot erase P. If AP mod 2 to the B is not equal to X, P XOR res dot pushback P res dot pushback One, two, 3, 4, 7, 8, 9, 10, 5, 27, 27 is 27 mod 8 is 3, 5, 6, yes. Okay. So 2, 1, so 11, 13. Then 1, 11. Then 3, yep. Then 5. Then 17, which works. Then 1, then 29, which works. Then 7. Okay, yes. Okay. Why? Oh. Yes. Can't exactly print 2 to the 20th things. Comp R 101. Yeah, okay, cool. Yeah, size 2 to the B. I mod 2 to the B, AI plus 1. That's X dot push, yeah. LF is 0 for LX size, F plus equals X mod 2. F continue, L source is 0. Size I is greater than 0, source is I. Go res. XY dot begin, PXY dot erase P, and PYX dot erase P. AP mod 2 to the B is not equal to X. PX equals 1. Yeah, okay. Revenge on this monstrosity because I didn't know what Euler Tor was. So I got a bunch of wrong answers trying to construct the path, even though I knew it was possible, even though I figured out the conditions. I never figured out Euler Tor, and so it just failed. I'm gonna TLE. This could TLE, actually. I hope not. Time limit exceeded on test 13. Ugh. Seriously, bro? B is local. Question mark 20. Colon 20. B is greater than or equal to 0. B minus minus. God damn it. Bro, what is it with TLE? Like, why? X is equal to RNG mod 2 to the 20. How slow are you? Do I have slow I/O or something? I don't get it. Do I need you to be int? You could be. You already are int. What? What? Are you n squared or just slow? Oh, I know why. Yeah, we're not gonna do you every time. What? Wait, that actually is not the difference. Okay, I mean, you're better, but... Is it constructing the walk, or is it? No. VL size 2 to the B, vector V nodes 2 to the B. Wait, what? Oh, I didn't delete you here. Idiot. Okay, that's so much better. There we go. Okay, yeah. Don't do the set thing every time. That's dumb. That's very dumb. That's like, that's horrible. Okay, well, you made it farther than this ever did. Beautiful. That's a lot of tests. Why are there so many tests of this problem? My God. Imagine if you fail on test 200. What? 2.6 seconds. Okay, wait, that's 2,500? Huh. I thought you were 23. Okay. I guess that makes this performance a little bit more justified. Still, though. Alright, well, that's enough of that. Enough of everything, even. We'll solve this tomorrow. Yes. Okay. We shall solve this tomorrow. That is the plan. Okay. I guess that's it. As always, if you want to chat, join Discord. If you want notifications, go there. Makes life easier. Otherwise, bye.